yung aking PowerPoint. So, while waiting for that, tinatry ko rin siyang i-troubleshoot. Unahin ko na muna itong gases. No? So, okay. So, medyo okay naman na we started gases kasi nakita na natin kung paano nagre-react kasama-sama yung mga atoms natin. No? So, again, we started with the atoms. We looked at how atoms are arranged in different models na binigay ng iba't ibang scientists through time. And then we later on realized na, hindi pala natin totally madidetermine yung lokasyon tsaka yung bilis ng galaw ng atom. So, we can't really fully detect or to identify kung nasaan yung electrons natin doon sa orbit niya around the nucleus of the atom. So, ang naging solution doon, yung naging solution ni Schrödinger, no, using the Schrödinger equation and combining the particle, what do you call this? Particle model and also the wave model of light, of energy. Nakagawa siya ng Schrödinger equation na yun naman ang ginamit through mathematical calculations na determine yung probabilities, no, kung saan natin pwedeng matagpuan yung ating electrons inside the atom. So using those knowledge, we were able to furthermore determine yung electron configuration ng ating mga atoms as well as yung arrangement nila sa periodic table. And then yung trends na nakikita na sa periodic table. And then finally, we were able to create Lewis structures of atoms as well as yung reactions or yung pag-combine ng different atoms natin to produce the different molecular geometries that we discussed last time. So, yun. So, medyo, ano naman na yun, in a general sense, we already have an understanding of what matter is, given how we saw paano nagko-connect or nagsasama-sama yung mga atoms natin. Well, at least yung mga electrons natin in an atom and yung yung ating mga atoms to form a molecule. So, what I wanted sana is to talk about paano naman nagsasama-sama yung mga molecule, no? Pero that's actually very small topic. So I can just once I get the PowerPoint, I can present that to you. So dito, what we can do now is start talking about the different forms of matter. So we have gases, liquid, and solids, di ba? Yun yung alam nating tatlo na, kumbaga, main types of matter. There are others like plasma, but we don't have to. Essentially, plasma kasi mga ionized forms of matter. And then for this one, we won't tackle plasma. We won't also tackle solids. Kasi yung solids naman, we don't have time to talk about them na. At saka iba yung, paano ba? Iba yung arrangement iba yung, parang it's a totally different approach pag aaralin mo kung paano nag-arrange yung atoms inside your compound, no? Kung paano arrangement ng solids as well as metals. May sarili silang form. Magandang foundation ng understanding ng molecules ang gases kasi nga they are mobile, gumagalaw yung kanyang mga molecules, no? And as we will see later on, maraming properties ng gases na magandang jumping off point ng discussion kung bakit kung to understand how matter works, no? Okay. So as I said, we have three basic types of matter, and this slide just summarizes them. So you have your solid, your liquid, and gas. So these are the physical states of matter. If you remember one of our first lectures, I showed you yung water in its different states. No? Merong water na solid, which is ice. Merong water na in liquid form, which is yung water that we're familiar with, the water that we drink. And then may water na in its gaseous state or yung tinatawag natin steam or water vapor. Okay? Yan, sabi dito, most but not all. I'll pull up my laser. Okay. Most but not all substances can exist in all three states. So, pwede yun, no? Pwede siyang mag-exist in three states. So, katulad na lang itong mga ito, you have your water, your benzene, your carbon tetrachloride. Depending on their temperature, they can exist on a certain state. So, we'll see those diagrams in, you've probably seen them already doon sa week 11 natin. Sa intramolecular forces natin na topic, no? Sa summary reading nyo. So for today, we'll talk about gases. So what are the typical properties of gases? So gases can be easily compressed. Naka-admit ko lang. Yeah. So some properties of gases, which you are probably familiar with, laser. They can be easily compressed into smaller volumes. So pwede silang i-compress pa, no, nasa mas maliliit na volumes daw. Their densities can be increased by applying increased pressure. Your gases exert pressure on their surroundings, and so yung pressure na yon must also be exerted to confine gas. So parang may sense of equilibrium, no, or balance doon sa surroundings mo, kasi yung gas mo nag-exert ng pressure on its surroundings, at as well as yung surroundings mo nag-exert din siya ng balance na pressure doon sa gases mo. They can expand without limits, okay? So they can completely occupy any volume ng container mo. So familiar naman tayo, di ba? So if you blow into a balloon, for example, hanggang pumutok na siya, you can still continue blowing into it, no? Kumbaga di na kinakaya nung container. But gases can continuously expand without limit. Gases can also diffuse into one another. So kung may pinagsama kang, for example, carbon dioxide and oxygen in one container, so they mix. Okay? Yeah. And then the amounts and properties of gases are described. Ayan. So there are certain properties of gases na kung saan pwede natin i-describe siya. And ang typical ones na pinag-uusapan when it comes to gases are temperature, pressure, and volume. Okay? And then you have also your number of molecules or number of moles. Okay? So temperature, yung apat na yan, temperature, pressure, volume, and number of moles. Okay? Yan. So as I said, no, to determine the state of the matter, meron kang different na basis. So you have your forces, your inter or intramolecular forces, na ito yung forces na naghahawak, kumbaga yung nagdidikit ng mga atoms natin and our molecules, no? And then your kinetic energy. Ito yung energy or yung enerhiya na nagko-cause ng movement ng ating mga atoms. Okay? Your inter or intramolecular forces, sila yung nagdidikit. Meanwhile, yung kinetic energy mo naman, siya yung parang nagpo-pull apart ng particles mo. So, dito, no, sa solids mo, dikit-dikit talaga yung molecules mo. Dito naman sa iyong liquid, medyo mas fluid siya, mas hiwa-hiwalay. And then your gases are totally apart. No? They're totally pulled apart. So, mapapansin nyo na because of that, ang gases mo have very high kinetic energies kasi they move a lot more compared sa iyong solids and liquids. Additionally, kapag mainit ang temperatura, your gas particles move faster. Actually, in a general sense, lahat naman ng every time na you increase the temperature, you input heat energy, no? So when you increase that energy, mas gumagalaw or nag-i-increase din yung kinetic energy ng part ng matter mo. So the particles move faster. It's just that with gases, mas apparent yun kasi nga in the basic sense, they are already far apart. So mas mabilis na yung paggalaw nila. But if you think about it, kunyari, let's take ice for example. Yung ice, di ba, solid siyang malamig, na 0 degrees. So kapag nag-apply ka ng heat, slowly, what's happening inside is that gumagalaw yung molecules mo because of the increase in kinetic energy na ina-apply mo through heat, no? So habang gumagalaw yung habang nag-increase yung kinetic energy mo, your molecules gain energy also to move around. So gumagalaw sila ng gumagalaw, mabilis, hanggang enough na yung energy, ma-breakthrough niya yung 4 degrees Celsius, no? Pagka-breakthrough niya ng 4 degrees Celsius, it starts melting into liquid. It starts melting into liquid. So, if you apply more heat, mas painitan mo pa, painitan mo pa na painitan yung liquid na yon, once you reach 100 degrees Celsius, the compound or your water has now enough energy to break into that gas territory. So, ganun yung idea na you increase their temperature, you increase the movement of your particle, you increase your kinetic energy, you increase the movement of your particle. That's why sa gases, no, ang bilis ng gumalaw noong particles mo. Kasi kumbaga, ito na yung state niya na enough with the applied temperature to such that it can move around. So, no, I'm just trying to to give you a perspective na okay, ang yung states of matter, hindi sila kumbaga magkakaiba. They are essentially parang ano sila, states, no? Kumbaga parang stages, kumbaga parang ganun ang dating. Depende sa kinetic energy as well as yung forces na nag-a-apply doon sa iyong molecules. So, some more characteristics of some more characteristics of gases, nabanggit naman natin kanina. They expand to fill any container. Okay? Fluids sila, like they are fluids. Okay, so when you say fluids, you refer to both gases and liquids. No? Tapos, they have very low densities. And then, they have lots of empty space. So, makita nyo naman dito sa diagram natin, no? Ang daming empty space for your gases. Yeah? Compared to your solids na dikit-dikit and your liquid na mas dikit-dikit there. Okay. Alright. Tapos, yeah. So, yung mga nabanggit na, they can be compressed, they can undergo diffusion and infusion. So, this diagram here, this is effusion. No? When your gas particles move through a barrier with small holes. Diffusion naman it's the movement from a place of low density, kumbaga mababa yung number of particles sa area na yon, doon papunta sa space na mas marami yung from a place of high density pala, kumbaga yung lugar kung saan marami yung particles na yon, papunta sa lugar na wala masyado ng particles na yon. So that's a very natural property of a lot of gases, most particular, no, mas obvious siya kasi nga kunyari, imagine mo mag-spray ka ng Lysol sa isang lugar. Okay? Spray ka ng Lysol sa bandang pintuan ng kwarto mo. Maya-maya naamoy mo na rin siya kahit doon sa higaan or sa window part ng kwarto mo. That's called diffusion. Your Lysol particles, yung in-spray mong yon, move from a place of high density, kung saan mo in-spray, papunta doon sa lugar na wala masyado. So that's diffusion. Effusion naman, it's like diffusion also, pero may involvement ng small holes, no? Kung saan siya nagpa-pass through. So to understand yung gases, what scientists did was to imagine or to think of gases or gas molecules as ideal gas. So anong ibig sabihin? So anong ibig sabihin ng ideal gas? So ang ideal gas, when we refer to it, para siyang para siyang ito yung ginamit na model. So I'll refer to it as a model. Ito naman yung ginamit ng model ng mga nagre-research on gases para mas madaling ma-calculate, mas madaling ma-observe or mas madaling maka-come up ng generalized equations para ma-calculate yung movement ng gases natin, mga gas particles natin. So sinabi nila, okay, sige, para mas maintindihan natin paano nagpo-function yung gases, baka pwede nating isipin yung isiping model ang isang ideal gas. So, dinefine nila kung ano ba yung ideal gas. Your ideal gas has no volume. It also has no elastic collisions. Ibig sabihin nun, your total kinetic energy is conserved kahit na nagtumatama sa isa't isa yung mga particles. So, okay. Di ba, imagine niyo yung billiard ball. Pag sa billiards, no? So, when you hit the ball with your, with the stick, no? Pag natamaan mo siya, mag-roll yung ball, tapos tatamaan niya yung isa pang bola. So, what happens then, yung kinetic energy nung bola na unang tinamaan mo, will be transferred to another. Yun yung nagkakos noong roll, noong tinamaan pa na bola, nung naunang bola. Pero kung mapapansin nyo, hindi na kasing bilis noong naunang bola yung pangalawang bola. Kasi meron kang loss of kinetic energy due to your elastic collision. So, I don't know if you've tackled this in your in physics, I mean in your senior high or in your high school. Pero may formula yung elastic collisions at saka inelastic collisions. Anyway, essentially what it's saying is dapat in reality merong nawawalang kinetic energy in the process of collisions, no? Katulad nga ng in-explain ko na with the billiard ball. Pero dito sa parang itong model or imaginative model na ginawa ng mga scientists to understand gases, sinabi nila na okay, let's assume na walang na hindi inelastic yung collision. Let's assume na elastic yung collision. So confusing pala. So, elastic collision, ito yung hindi nawawalan ng kinetic energy. Yung billiard yung billiard ball na in reality, no, pag bumabagal yung tinamaang particle, that's called an inelastic collision. Kumbaga, yun may loss of kinetic energy. So, ang inassume nila for ideal gas ay, ang inassume nila for ideal gas ay elastic. Kumbaga, hindi nawawala yung energy as the particles hit each other. Okay. So una nilang assumption ay walang volume na ina-assume yung ideal gas mo. Pangalawa is walang meron siyang elastic collisions, which is hindi nawawala ng kinetic energy. Ay, wait lang, may isa pa. And then, the last, hindi pa the last one. They are in constant random straight line motion. So, ganun yung, yung, parang assumption nila sa ideal gas. Constantly, randomly, straight line ang motion. Tapos, hindi yung mga molecules, hindi sila nag-attract or nagre-repel sa isa't isa. Tapos, yung kanilang kinetic energy is directly related to their temperature. Okay. So, okay, again, this is the idea of an ideal gas, no? This is not what happens in reality. Pero, again, we're using this model para mas madali nating intindihin at maka-determine ng equations that will define our gases. So, in the real world, yung real gases natin actually have their own volume. They actually attract each other with intermolecular forces. Tapos, in the real world, nagmumukha lang ideal gas, yung mga dinescribe natin kaninang slides, no? Nagiging ganun lang or nagiging similar lang to that properties ang ating real gases kapag ang gases mo ay in low pressure at in high temperatures. Okay? So, mukha lang, in the real world, yung gases daw natin, meron talagang sariling volume at nag-a-attract sila sa isa't isa, no? Thus, having also inelastic collisions due to intermolecular forces. Pero, we can achieve ideal gas behavior. Kumbaga, parang nagiging ideal gas ang quality nila kapag ang gases mo ay mababa ang pressure at mataas ang temperature. Kapag so just imagine, no, kung mababa ang pressure mo, ibig sabihin hindi mo masyadong kinocompress yung gases mo. At the same time, pag mataas ang temperature mo, sobrang bilis ng movement ng atoms mo. Such that it achieves yung parang ideal gas behavior nga na sinasabi natin. Ay, may Y pala doon. So, yun. Sinabi ko na yung Y. Ayan. Okay. Ito pala. Okay. So, ito yung sinabi ko kanina. At STP, ibig sabihin standard temperature and pressure. Yan ang ibig sabihin ng STP. Yung molecules mo daw ng gas, mabilis na mabilis ang galaw, tapos magkakalayo sila. Okay? Such that, so dahil sa ganun yung property nila, mabilis sila at magkakalayo sila, yung intermolecular forces nila, kumbaga yung forces na nag-a-attract sa isa't isa, tsaka yung volume na meron sila, are already insignificant. No? So, hindi mo na, parang, kahit hindi mo na i-consider yun, parang they're already approaching their ideal gas state. So, assumptions of ideals are valid under normal temperature. But, okay, at high pressures, ang gas molecules mo are pushed closer together. Okay. So, balik na rin natin. No? Kasi di ba kanina pinag-uusapan natin kanina, sabi ko, na kapag mababa ang pressure at mataas yung temperature, nagmumukhang ideal gas yung real gases mo. So, ano ba yung epekto kapag naman binaliktad mo yon? Paano kapag mataas yung pressure at mababa naman yung temperature? So, kapag mataas yung pressure mo, nagiging significant yung volume kasi mas dikit-dikit na yung gas particle, yung gas molecules mo. So, meron ng, kumbaga, we have to consider already yung actual volume nila, no? na meron yung gases mo. Tapos, kapag naman mababa yung temperature, mabagal din yung paggalaw ng particles mo, which means nag-i-start ng gumana yung intermolecular forces. Kumbaga, hindi mo na pwedeng hindi pansinin yung presence ng intermolecular forces pag mababa ang temperature at mabagal ang galaw ng iyong mga gas molecules. Okay? So, yun. At high pressure and low temperature, hindi mo pwedeng i-assume na ideal gas behavior yung nangyayari sa gases mo. Okay. So, I hope that's clear so far. Okay. Again, what I'm just pointing out here is para lang siya, no? Para lang maintindihan ng mga researchers or scientists yung properties ng gases. They made this parang model of an ideal gas with these properties. Pero again, in reality, iba yung nangyayari sa real gases. Okay? Pero, yung real gases can achieve or parang kamukha niya yung ideal gas na model kapag mababa ang pressure at saka mataas ang temperature. At yun ay dahil sa pag mababa ang pressure at mataas ang temperature, hindi mo na kailangan pansinin yung intermolecular forces as well as yung volume ng gases. And that is, pag binaliktad mo naman yan, pag mataas naman yung pressure at saka mababa ang temperature, doon mo na pwedeng intindihin, kumbaga, or isama sa calculation mo yung volume at saka yung intermolecular forces. Hindi na siya ideal gas. Real gas equations na yung gagamitin mo. Okay. So, I've been talking about pressure, these properties mula kanina. No? We have nabanggit ko yung pressure, temperature, volume, and your number of moles. So, padaanan lang natin sila, although we've tackled them a bit noong umpisa ng ating semester. So, your pressure, again, is your force per unit area. Okay? So, ito yung puwersa na ina-apply mo in a certain space. Okay? So, imagine, paano ba? Imagine if you're wearing a rubber shoes and if you're wearing stiletto. Stiletto ba tawag doon? Yung may heels na matulis. Stiletto. Okay. So, imagine mo kung suot mo ay rubber shoes compared sa stiletto ang suot mo. Tapos, inapak mo siya sa foam, for example, sa higaan nyo. No? Huwag nyo gagawin yun, no? Kasi madumi yung shoes nyo. Pero kunyari, inapak nyo siya sa foam ng higaan. So, yung pressure na ina-apply mo kapag rubber shoes yung suot mo, hindi ganun kabigat kasi spread out doon sa flat, di ba flat ang surface ng rubber shoes? Spread out doon sa flat surface yung ina-apply mong pressure. Pero imagine mo kung stiletto, no? Inapak mo doon. Kung may tao doon sa ilalim, baka ano, baka patay na. Hindi naman patay, pero kung ano nangyari doon sa tao kasi ang tulis, 'di ba? So essentially pareho lang naman ng weight mo, pareho lang naman yung bigat mo. Pero yung because you are applying your force on a smaller surface, yung stiletto, 'di ba, ang liit ng surface niya sa ilalim kasi nga heels siya compared sa rubber shoes. Mas masakit or mas mabigat yung pressure na nararamdaman noong foam or nung kunyari tao nga doon na naapakan. No? So yun yung idea, no? That's pressure. So it's force per unit area. Depende sa, you can have the same force, pero kung mas maliit yung area na nag-a-apply, mas mataas yung pressure mo. Okay? Isa pang, admit ko lang. So yeah, so that's one way to visualize pressure. And then, what's happening here? You have this is your bromine gas. No? So, sa lab, if you have bromine, tas buksan mo yung flask na laman ng bromine, tas takpan mo ng beaker, pagtagal ng panahon, mag-iiba yung kulay noong hangin sa loob. So, that's diffusion, no, na nangyayari. Well, you can also, hindi naman small hole, no? Pag effusion kasi small hole. Okay. Parang mali yung figure. Hindi, kasi ang nilalagay dito is dapat yung mercury barometer. I think ayan, ito yun. So, ito yung ginagamit, especially before, no? Na pang-measure ng pressure. So, you have your mercury liquid. Yan. Tapos, it creates this vacuum inside. Tapos depende sa pressure sa labas, dito yung outside pressure mo. Yun din yung height na makukuha mo rito. Okay? I mean, magko-correspond siya dun sa height na makukuha mo rito. So in that way, you can actually calculate yung pressure of your atmospheric pressure in your atmosphere, or what we call atmospheric pressure, or your P sub ATM. Yeah. Okay. So, depende sa atmospheric pressure mo, gumagalaw yung mercury. And then, using the height, yan, kunyari ito, height difference naman. You can determine your atmospheric pressure. So, kunyari, meron kang gas of known pressure. Equal dapat yung pressure of the gas in torr doon sa pressure ng atmosphere or yung pressure sa labas, no? Plus H torr. So, itong H na to, ito yung height. Okay. So, anyway, I don't really want to focus on the calculations for this one. Ano ba to? Barometer. Ayan. So, ito yung parang ginagamit before, no? Before pa nagawa yung mga typical barometers. And then today, ganito na yung mga mas commercial na barometers that we use every day. So, pressure, when we calculate pressure, just remember na yung atmosphere ang ginagamit natin madalas na unit of pressure. And 1 atmosphere is equivalent to 760 millimeter mercury. So, that's mmHg. That's millimeter mercury. That's at 0 degrees Celsius. Okay? At 0 degrees Celsius, you have at 0 degrees Celsius, itong 1 atmosphere at 760 millimeter mercury, dapat equal din siya sa 760 torr. Okay? So, these things, these are just units of pressure. Actually, maraming ang units of pressure. Ang actual na SI unit ng pressure ay Pascal. Okay? So, iba pa yun. Pag kinalculate mo, tignan mo naman ito. 1 atmosphere of pressure is 1.01325 times 10 to the 5th power Pascal, or 101.325 kilopascal. So, yun. Pag nag-exam kami, tapos pressure yung topic, dapat memorize mo yan. Yung mga conversions na yan. Kasi minsan, bibigyan ka ng question na ang given ay torr, kunyari torr ang given, pero pinapahanap in Pascal yung sagot. Or yung choices mo nasa Pascal. So kailangan marunong ka mag-convert using dimensional analysis, knowing these conversion factors, no? Well, at least sa inyo naman, since medyo open notes naman pag nag-exam kayo, you can just refer to your notes, no? Kung ano yung conversion factors na pwede nyo gamitin. Okay, ano ba? Okay, so medyo tricky din when it comes to gas calculations. Yung paggamit ng, kunyari, yan, no? Di ba, force over area ang pressure natin. And ang measure ng force is what we call Newton. Okay? So ang Newton, hindi siya SI unit. It's a derived unit. Pero kung i-breakdown mo siya into SI units, which is a skill that is very important, no? Ito equivalent niya. 1 Newton is equal to 1 kilogram times meter per second squared. Okay? So, kung yun ang equivalent ng force, this is force, at sinabi natin kanina na pressure is force over area. So, di ba ano bang area? Area is just your measurement of the length of one side times squared times itself, no? So meter squared or cm squared, yun. Pero SI unit natin is meters, di ba? So meter squared, big pa lang sabihin nun, pwede natin i-cancel yung meter dito, maka-cancel siya, tapos mata-cancel yung isang meter dito. Ang equivalent ng isang Pascal, which is your SI unit for your pressure, is 1 kilogram per meter second squared. Okay? So, ganyan siya. Pero ako, what I do usually is just I memorize this. Kung ano ba yung equivalent ng isang Newton. Tapos I just derive it on, kunyari during exam, I derive it on the spot. Kasi mas madali kaysa yung i-memorize mo lahat ng, dapat ang 1 Pascal ay 1 kilogram over meter second squared, ang 1 Newton is equal to. So, okay na yung i-memorize mo lang yung isa, tapos since alam mo naman na yung formula, doon ka na mag-start mag-derive ng units mo. Okay, so, yan. Ayun pala may konting illustrations dito. So again, that's pressure. Okay, so this is just, alright, ayan. So ito yung parang summary nung kanina. So meron pa yung PSI, no? So siguro baka narinig ito pag sa bike, yung tires mo, kung ano yung PSI na ginagamit, or sa mga motor, ano yung PSI mo. So yun, that's also pressure. That's gas pressure actually. So that's pounds per square inch, pound per square inch. And so yeah, no, sa loob ng mga tire ng kunyari kotse, those are gas molecules, di ba? So they exert pressure para ma-form yung para ma-form yung iyong tire, di ba? Kung hindi siya nag-exert ng pressure, malalambot lahat ng natin, gulong natin. Pero dahil they exert a certain pressure, matigas tsaka kayang mag-roll ng maayos. Tapos depende rin sa pressure na ilalagay mo. So that's why we have PSI. Pag kunyari magpapalobo ka ng magpapahangin ka ng wait lang, admit ko lang yung classmate. Yan, magpapahangin ka ng gulong, no? Kunyari malambot na. So minsan pwede mong iset, sabihin mo kung anong PSI yung kailangan mo. Okay. So, sir, ano yung atmospheric pressure na binabanggit nyo kanina? Ito yun. Essentially, yung lang siya, pressure ng gas molecules mo sa atmosphere. Okay? Kasi, if you remember, may gravity, di ba? So, because of gravity, mas mataas yung pressure mo mas pag malapit ka sa Earth. No? So as you go further sa Earth, mas konti na lang yung pressure. So ibig sabihin, mas freely gumagalaw yung gas molecules mo. Wait lang nga. Okay. Tama naman pala. Okay. So pag malapit ka sa Earth, dahil nga sa gravity, mas na-pull down yung gas molecules, no? So mas concentrated, no? You can think of it as mas concentrated yung gas molecules dito. Mas mataas din yung pressure, okay? Kasi nga your gas particles are plentier doon sa baba, no? Baba, sa malapit sa Earth. So they exert more pressure also, no? Kumbaga nag-occupy sila mas maraming space. As you go up in the atmosphere, pakonti ng pakonti yung gas particles mo. Ganun, pakonti rin ng pakonti yung gas molecules mo. Kaya if you, ewan ko kung may experience kayo hiking sa mga bundok, nangyari Mount Makiling, no? Ano yung inakitahan before? Mount Makiling, tsaka yung mga bundok sa Palawan or Davao, ganyan. Pag umaakyat ka na, mararamdaman mo na mas mahirap ng huminga. Kasi nga, mas konti na yun yung sinasabi na the air is thin up in the mountains. Kasi mas manipis na yung hangin, mas konti na yung air particles mo. That's why you kind of have to breathe in more ng mas paulit-ulit para may masustain kang hangin. Kaya mahirap din umakyat ng very high altitudes. No? So, that's your atmospheric pressure. No? Essentially, yung pressure ng gas molecules mo in your atmosphere. So, yun ano lang rito, parang trivia ba to or ano lang. Why do your ears pop in an airplane? Kasi nga nag-iiba yung yung pressure mo as you go up, 'di ba? Pag nag-ascend yung airplane, nag-iiba yung pressure. So, I think may part ng ear inside na it adjusts to your pressure or it's affected by pressure. So, yun yung parang nagpa-pop na part na pag nag-a-adjust ka ng pressure. Hindi lang naman pag airplane, di ba? Kunyari pag akit ka ng Baguio sa bus, parang midway, naramdaman mo na yan, nagpa-pop na. Tapos, ewan ko kung na-experience yun rin to, na kapag umakit ng Baguio, yung, ano ba? Yung mga chips, yung mga baon nyo sa field trip, ganyan, kunyari, yung mga chips na baon nyo, ano din sila, parang lumolobo, mas nagiging parang maximized yung yung size nung mga chips or nung mga mga junk food na dala-dala nyo. Ako napansin yun. Pero yeah, so we'll see later, no? Maintindihan natin ba't ganun yung nangyayari. Okay, sige. Okay, so we've tackled pressure. Now let's tackle temperature. You have your Kelvin scale. Okay, so this is familiar already to you. Pinag-usapan na rin natin ito early on. So your Kelvin scale, your Celsius scale. Okay? Again, this is your formula. Okay. So kung maalala niyo yung binanggit ko before na through calculations of thermodynamics or yung heat, no? Na-determine ng isang physicist, si Lord Kelvin, na there's this what we call yung absolute zero, at which yung motion ng particles mo ay zero. Okay? So your gas is actually not moving already. So these are just some references to understand further ano ba yung absolute zero na ito. No? Kumbaga, just imagine guys, your gas particles are not moving. Pero that's at negative 270 degrees Celsius naman. We've never reached that temperature, okay, in any of our equipment in the laboratory. I mean, in anywhere in the world. No? Hindi pa siya kaya ng technology natin na abutin yung negative 272 degrees Celsius. Pero technically, yeah, what we know is that at this temperature, mag-stop lahat ng movement ng particles mo. I think the nearest we've gotten is negative 170 yata degrees Celsius. So, it's very low already, pero nowhere near itong negative. Okay? I need this negative 273. But again, this is due to calculations, no? Doon nila na-achieve yung number na yan. So, siguro lang, no? Baka kasi meron tayong notion na 0 degrees yan diyan 0 degrees Celsius diyan nag-freeze ang lahat. So, ang 0 degrees Celsius, ano lang siya? Ang nag-freeze lang doon, well, hindi lang pala 'yun. Pero kaya naging yung Celsius scale, ang ginawa yung Celsius scale based on water kasi. So, sinet nila ng 0 degrees ang freezing, tapos 100 degrees ang boiling. So, kaya mas, kumbaga, mas unbiased, no, yung Kelvin scale. Kasi yung Kelvin scale, it is from calculations nga ng thermodynamics. So, hindi lahat nagpe-freeze sa 0 degrees, ha? Hindi lahat ng elements or hindi lahat ng compounds nagpe-freeze doon. Again, yung kaya nga lang siya naging 0 degrees Celsius, sinet kasi nga doon yung freezing point ng water. Pero for all substances, for everything else in the world, in the entire universe, motion will stop at, tama ba to? At absolute zero. At zero, hindi zero Kelvin. Ay, tama. Yes. Tama. Zero Kelvin, all motion will stop. Okay? So ano ba yung 0 Kelvin? If you convert Kelvin to Celsius, that's negative 273 degrees Celsius. So at negative 273 degrees Celsius, or what we call absolute zero, which is 0 Kelvin, all motion of all particles in the known universe will stop. Okay? But again, we've not reached that. It eliminates the use of negative values. Okay? Yeah. So anyway, yan. Sabi niya lang bakit magandang gamitin yung Kelvin. Okay. You have your temperature, volume. Yan. Just shows ito. Ito yung negative 200. Kapag i-use yung Celsius scale, may negative ka. Pero kapag gamit mo ay absolute, yung Kelvin scale, wala kang negative. Okay, alam niyo na yan. Been through that na. Ayan, so ito na. Okay. So ito talaga yung parang main ng gases. Now, we've laid down the foundation. Pinag-usapan natin yung pressure, volume, temperature. Pinag-usapan na natin yung characteristics ng gases mo. Ang kumbaga essence ng gases topic mo ay yung pag-lay down ng gas laws. So ito na yung diba, pinag-usapan din natin kung paano nilay down yung ideal gas, no? Tsaka yung difference niya from the real gas. So pag sasama-samahin natin lahat ng mga nilay down nating topics kanina, and we'll go into the different laws of gases. Okay? And we start with Boyle's law. So imagine that you hold the tip of a syringe on the tip of your finger, so no gas can escape. Now push down on the plunger of the syringe. What happens to the volume in the syringe? What happens to the pressure the gas is exerting in the syringe? Okay? So, yan, imagine nyo lang yan. Just a thought experiment daw. Nahawak mo kunyari yung dulo ng syringe mo, no? Tinakpan mo with your finger na walang gas na maka-escape. Tapos ipupush mo yung plunger. Ito yung plunger mo, no? Ipupush mo raw siya. Ano nangyayari doon sa volume sa loob? At saka ano nangyayari sa pressure, no, ng syringe mo sa loob? So, ako, kapag tinatry ko to, napupush ko naman siya at a certain volume, pero at a certain pressure. Pero pinupush back niya ako. Okay. Tapos, sorry. So, si Boy, nausog. Ano ba ito? Bakit may PNV rito? Huwag mo napansinin. So, based on experiments, si Boyle, you have Charles Boyle, he determined yung volume pressure relationship. So, he determined that your pressure and your volume of a gas are inversely proportional. So, kapag, ano ibig sabihin ng inversely proportional? Kapag yung isa ay nag-i-increase, yung isa ay bumababa. So, this is at constant mass and temperature. So, kapag pareho yung temperature at pareho yung number of moles ng gas mo, nakapansin mo daw na ang pressure ng gas mo, kapag nag-i-increase siya, mababa ang volume mo. Kapag naman nag-i-increase ang volume mo, mababa ang pressure mo. So, that's what Boyle's law is. No? Summarize that in an equation. Ito yung makukuha mong equation. Your P1V1 is equal to P2V2, where P1 represents yung initial pressure mo, your V1 represents your initial volume, tapos your P2 represents your final pressure, and your V2 represents your final volume. So, na-achieve lang to using this relationship. No? So PV equals K, where K is a const, your, tawag dito? Ano yung K? Ratio, proportionality constant. Yun. Came to me. Pero hindi nagagamit yung word na yun. So, yung K mo, di ba, when you talk of proportions, meron kang nilalagay na proportionality constant, no? Para pang balance. Ay, hindi na pang balance. It signifies yung relationship noong dalawang variables mo. Okay. So, ganyan, no? Ganyan yung relationship ng dalawa. Your volume is equal to K times 1 over P. Ano ba? Yeah. So, tingnan nyo rito. Pag, is atmospheric pressure. When you increase your pressure, lumalaki yung volume. Ano ba? Dapat, when you increase your pressure, dapat lumiliit ang volume. So ito, volume 1, ito yung volume 1 mo. So nag-increase ka ng, nag-add ka ng mercury. So nag-decrease ka ng pressure. Ay, hindi. Nag-increase ka ng pressure. Lumiit yung volume mo. Okay. So this is your volume 1 at your pressure 1. Tapos, pansin mo rito na lumiit yung volume mo, which means tumaas yung pressure mo dito sa, I think ginamit niya yung additional mercury to increase the pressure. Oh, pero pwede ba yun? I'll double check this one. I'll clarify this. Pero ganun essentially. It's actually trying to visualize what's happening, pero parang hindi ganun ka-effective yung visuals niya. Ayan. So, this is just a graphical data. Okay. Kanyari meron kang graph. Tapos, I think sa, dun sa lab counterpart nito, if we do the experiment, meron kayong graphical data na ma-achieve. Tapos, what I typically do is, I ask students will have to make this table, tapos make this graph. Tapos yun yung parang parang output nila for that experiment, yung graphical representation. At pag makikita mo nun, pag ginraph mo, makikita mo yung relationship. So, ano to? Kapag volume versus pressure, hindi siya linear, hindi siya curved siya, asymptomatic siya. Asymptotic, COVID yarn. Asymptotic yung yung graph mo. Pero kapag ang ginamit mong ang ginamit mong scale ay volume versus 1 over pressure, kasi nga 'di ba we know na they are inversely proportional. Makikita mo na straight line. Ibig sabihin nun, tama yung yung proportionality na ginagamit mo, which is inversely proportional nga. Okay? So again, this is kung maganda yung foundation nyo sa basic algebra nyo, your equation of a line, for example, no, they are very much used in a lot of chemistry experiments. Okay? Yeah, okay. So, yun. Ito mas gusto kong visual siguro, no? Pwede mong imaginein kasi parang nga yung syringe na kapag pinupush down mo yung increase the pressure onto your gas, syempre, mas maliit yung volume. Okay? So, parang ito yung mas gusto kong visualization niya. Okay, so, yan. You can also use the formula that we have earlier to determine kung ano yung magiging end up na volume mo. So, example nito, kunyari meron kang gas na may volume na 12 liters under a pressure of 1.2 atmosphere. Ano daw yung volume na magiging resulta kapag in-increase mo yung pressure to 2.4? What you just do is you use your Boyle's law formula kanina. Your P1V1 equals P2V2. Very similar siya dun sa M1V1 ng dilution sa lab, di ba? Yung M1V1 times M equals M2V2. So, ganun lang. No? You just plug in the numbers that you're given and you realize na, okay, you get 6 liters na volume kapag in-increase mo yung pressure to 2.4. Which kind of makes sense because your 1.2 is just your 2.4 is 2 times your 1.2. So, you kind of expect na magiging half naman ang mangyayari doon sa volume mo. You're from 12, magiging half siya into 6. No? Okay. So anong dito sinasabi, anong units ang gagamitin mo? Basta make sure na same ang units na ginagamit mo para mag-cancel out din sa dimensional analysis mo yung atmosphere. So ito magka-cancel yan. So just make sure that you're using the same units when you're doing. Kasi kapag ang given mo, yung isa ay binigay na, for example, mmHg or millimeter mercury. Tapos yung isa ay atmosphere. Kailangan pa mag-convert ng times 760, di ba? Just to, using the conversion factor. So, you try. Okay, so this is for you to try na. Pag pinost ko na lang yung PowerPoint. Okay, so that's Boyle's law. Essentially, it's saying na we inverse ang relationship ng pressure sa volume. So kapag in-adjust mo or kapag in-increase mo yung pressure, lumiliit ang volume. Pag in-increase mo ang volume, lumiliit ang pressure. Okay, so this is Charles. Yung other law, which is Charles' law, is this one. So sabi niya dito, Charles' law is the volume temperature relationship. And it uses the absolute temperature scale. So imagine that you put a balloon filled with gas in liquid nitrogen. Parang ang pangit naman pala ito. Kasi I'm not sure if you have experience using liquid nitrogen. So imagine daw na mayroong kang balloon na mayroong gas. Tapos nilapag mo siya sa liquid nitrogen. So for FYI, liquid nitrogen is a very low temperature siya, no? Sobrang lamig niya na gas. So imagine niyo na lang bakit ganoon? Kasi sige, relatable naman pala. So 'di ba, katulad sabi ko kanina, ngayon at room temperature, yung nitrogen hindi naman natin siya nakikita, 'di ba? Kasi it's in a gaseous state, diba? At room temperature. Pero kapag binabaan mo yung temperature niya, pinalamig mo ng pinalamig, ng sobrang lamig, it can actually become a liquid. Okay? So at a certain temperature, na marireach noong nitrogen mo, pwede siyang from gas maging liquid. So that's super low temperature. Sobrang negative degrees Celsius na siya. So yun ang liquid nitrogen. And it's used in laboratories for experiments, no? So for example, ako sa thesis ko, I use it for extracting para mabilis ma-freeze yung mga samples ko. And then I can extract the RNA or DNA. So essentially, sinasabi niya, anong mangyayari daw sa gas in a balloon kapag in-expose mo siya sa sobrang lamig na temperature? Anong mangyayari sa volume ng balloon mo? Okay. So ganyan siya. From here, lumiit yung volume ng iyong ng iyong balloon. Okay. So bakit ganun, no? Bakit we have Charles' law. Sabi sabi ko kanina Charles Boyle, no? Hindi siya Charles Boyle, Robert Boyle nga pala siya. Si Charles pala ay ibang tao. So Charles' law, you have your relationship between your volume and your temperature. Okay? So essentially, sinasabi lang nito na your volume is directly proportional to your temperature, to your absolute temperature. So what does that mean? Kapag nag-increase ang volume mo, nag-increase yung temperature mo. Kapag nag-increase yung temperature mo, nag-increase din yung volume mo. Okay? So yun lang naman ang ibig sabihin ng trust law. Tapos yung formula na you can derive, pag ito yung, syempre you have your proportionality constant. No? When you use your formula na, when you derive the formula using this one, ito yung makuha mong formula from your Charles law. So V1 over T1 is equal to V2 over T2. Okay. So, yan. So, parang katulad lang sa Boyle's law kanina, tinry niya lang i-graph, showing nyo na directly proportional yung dalawa. So, that's why hot air balloons work. Okay? Kasi, if you remember, ewan ko kung napunta na kayo dun sa hot air balloon festival sa sa Lubao, sa Pampanga, sa amin yon. Actually, sa amin yon, pero di pa ako nakapunta. Ewan ko kung babalik pa nila. So, yun. So, how does it work? Di ba, merong fire, di ba? May flame doon sa gitna noong kung saan ka nakatayo. So, yung flame na yon, it heats up the air, thus expanding your volume ng gas mo. Kaya nag-i-inflate yung hot air balloon, and when it increases in volume, what happens is, sige. So what happens kapag nag-increase yung volume? Based doon sa mga diniscuss ko so far. Diba? Ininitan mo siya. Tapos, nag-expand yung volume. So, what else will happen with the air inside? So, since nag-expand yung volume mo, sige, since nag-expand yung volume mo, based on Boyle's law, bababa yung pressure mo, right? Diba? You remember? Bababa yung pressure mo. Oh, tapos, ano yung sabi natin kanina? Di ba yung pressure kapag malapit sa lupa ay mataas? Pero kapag nasa taas, nasa bandang taas ng, sa bandang atmosphere, mas mababa. So what happens is, since mababa na yung pressure mo sa loob nitong balloon, aangat na siya. Kasi hahanapin niya yung place kung saan mababa rin yung pressure. Okay? So, property yan. So that would be like, basta it will try to achieve yung level of pressure also that it has. Okay? So yung tatapatan niya, di ba? Katulad ng sabi ko kanina, yung we discussed kanina na dapat yung atmospheric pressure mo, pantay siya doon sa pressure, doon sa loob ng container mo. Parang it always tries to reach that equilibrium. So dito, since bumaba na yung atmosphere, yung pressure niya sa loob, because in-increase mo yung temperature at lumaki yung volume, hanapin niya ngayon yung place kung saan kasing level niya yung atmospheric pressure. That's why it floats. Okay. So that's the science behind your hot air balloon. It will pwede mo ring tignan sa density, no? So dito nga, no, sabi niya rito yung density. 'Di ba? Ang idea ng density is pag pareho yung density, nagpapantay sila, no? So isipin mo, paano ba? Kapag meron kang plastic, pinatong mo sa tubig, hindi siya lulubog, di ba? Kasi mas dense yung water doon sa tubig. Mas dense yung water kaysa roon sa plastic. Pero kunyari, maglagay ka ng gold bars. Gold bars talaga. So pag kunyari may gold, tapos nilagay mo sa tubig, babagsak siya. No? Kasi mas dense, mas mabigat, mas mataas yung density ng gold doon sa water. So, ganun din, no? Yung sa atmosphere, pag mas malapit sa lupa, yung gas particles, mas dense sila kasi nga pinupull ng gravity. Whereas sa atmosphere, mas mababa yung density. So, dahil nga in-increase mo yung temperature, nag-decrease yung pressure, so less dense na yung less dense na yung hangin mo sa loob ng hot air balloon mo. So, aangat siya kasi nga mas mababa na yung density niya compared doon sa density ng hangin dito sa malapit sa lupa. No? So, ganun yung idea. Kaya lumulutang, kaya nagpo-float yung hot air balloon mo. Ay, yun. So I hope you understood that. I mean, actually, mas gusto ko ano yun, na-appreciate nyo yun, yung mga ganung bagay, para mas relatable din kung bakit importante natin matutunan itong Charles Law, itong Boyle's Law. And these things were, again, itong mga ano na to, itong mga calculations na to, tsaka itong mga realizations na to, these were determined by assuming yung model ng ideal gas law. Okay? So, babalikan natin why models are important. Okay? Although they don't exist, pero dahil nga we tried to imagine it that way, yung mga ideal gas law, doon natin na-achieve yung understanding natin ng mga laws na ito. So, yan, okay? So, when balloons filled with air are cooled, no, nag-shrink sila. So, mali pala, no, yung sabi ko kanina, yung pagmakit ng bagyo, baligtad pala. Dapat, mag-shrink siya kasi mas mataas yung temperature, mas mababa yung temperature sa bagyo. No? Mas mag-expand naman siya kapag bababa kasi mas mataas yung temperature sa baba compared sa bagyo. Okay. Yan. Okay. So, yan lang. One way you can also think about it is ganito. Okay. And if you use that, wala. Hindi ko na ilagay. Anyway, it's just like using yung yan, ito. Just plugging in your values. Basta make sure nga na same yung temperature, yung units mo. Kapag hindi same ang units mo, mag-convert ka muna. Okay. So, STP, your standard temperature and pressure. Meron tayong tinatawag na STP, parang para mas simplified, no? Ano lang siya, ginagamit siyang term to simplify yung calculation. So, basta pag sinabi sa problem na at STP, agad-agad, you know that it's referring to 0 degrees Celsius or 273 Kelvin and 1 atmosphere or 101.325 kilopascals. Okay? Yun agad yun. Basta ang standard temperature and pressure mo ay 0 degrees Celsius at 1 atmosphere. So, yan yun. Okay? So, 1 atmosphere is equivalent to 760 torr, equivalent to 760 millimeter mercury, equivalent to 14 point something PSI. Okay? So, your conversion factors na huwag kakalimutan. Yan. Okay. So, hindi na-discuss yung Gay-Lussac's, no? Anyway, sige. Hanapan ko na lang yan ng ano. So, pag pinagsama mo yung, yung gas loss mo, you achieve this, no? This formula. P1V1 over T1 equals P2V2 over T2. And you have your combined gas law equation. So, yeah. Yeah. So, this is an example of using that calculation. Actually, it's very easy to use lang din naman. Again, you're just essentially plugging in your values, no? Ang pinakamahalaga lang talaga, make sure na same yung units mo para magka-cancel out and you get your final answer. So, kung ano yung matitirang unit mo, yun yung final answer. And then, a gas occupies, example problems. You can just determine that on your own. Calculate those on your own. Okay. So, Avogadro's law, So, the third one is what we call the Avogadro's law. No? Essentially, what it's saying is, pag equal ang volume of gases mo, they contain the same number of molecules. Okay? So, pag in-analyze mo sa proportionality, that means that they are directly proportional to each other. And similar to Charles Law, yung ganito yung magiging formula man na makuha mo kapag ginamit mo yung proportionality constant na yun. And then your standard molar volume, okay? So hindi siya nasama sa STP, pero pag sinabing standard molar volume, that's known already to be 22.414 liters per mole at STP. Okay? So kapag if you have STP, conditions, you have standard temperature and pressure, agad-agad, alam mo na your ideal gas will have a molar volume of 22.414 liters per mole. Okay? Agad-agad yun. So, okay. So just remember, no, you have your Charles law, you have your Boyle's law, you have your Charles law, and then you have your Avogadro's law. Pag pinagsama mo yung combined gas law, I showed you kanina, P1 V1 over T1 equals P2 V2 over T2. Tapos your last inintroduce na law is your Avogadro's law. Just essentially saying na directly proportional din ang volume sa number of moles. Tapos, at STP, or at your standard temperature and pressure, your molar volume is 22.414 liters per mole. Okay, so we can summarize all those laws into what we now know as the ideal gas law equation. Okay? Pag pinagsama-sama natin yan, makukuha natin yung formula na ito, which is your PV equals nRT. Yung R dito, this is called the universal gas constant. Okay? This was determined using experiments then. So your R, which is equal to PV over NT, is equal to so pag in-input mo dyan yung values for your STP conditions, makukuha mo yung value ng R mo, which is your gas constant, which is equal to 0.082057 liter atmosphere per mole Kelvin. Okay. So oftentimes it is rounded off to 0.0821. So take note of the units, no, of your R, of your gas constant. It should be liter atmosphere over mole Kelvin. So if you're working on a problem that is not using liters, for example, kunyari decimeter cube, ay equivalent lang pala yun. Kunyari meters cube ang gamit niya na volume unit, or torr, no? Or Fahrenheit, ganyan. You still have to convert. Okay? Kasi hindi mo naman pwedeng baguhin yung, well, pwede mong baguhin, basta kailangan mong mag-convert, no? Such that magka-cancel out yung units mo in your dimensional analysis. Okay? So yun yung medyo nagpapahaba actually ng mga calculations sa gases kasi nga ang daming kino-convert pag iba-iba yung units na given. So, yan, okay? R can have energy units per mole per Kelvin. So this is an example of using that formula. Pero what this wants to show is that you can also show your R, your gas constant, in another set of units. So minsan din kasi, or in a lot of calculations of energy, joules ang ginagamit. So joules is the unit of energy, no? So pwede mo rin ipakita actually yung R, your gas constant, as in the form of joules, no? Kasi we know that 1 liter atmosphere is equal to 101.325 joules. So pag ginamit mo yun as conversion, makuha mo itong another version of your R, your gas constant. It's 8.3144 joules per mole Kelvin. Again, this is just equal to yung number kanina. Magkaiba lang sila ng units. So, depende sa given mo. You can make use of these different values. No? Yeah. Just make sure na magka-cancel out ng units mo. Okay. So, ito naman, so this is just an example of using the ideal gas law. So a helium-filled weather balloon has a volume of 7,240 cubic feet. How many grams of helium would be required to inflate this balloon to a pressure of 745 torr at 21 degrees Celsius? Okay. So cubic feet is equivalent, 1 cubic feet is equivalent daw to 28.3 liters. So essentially, ang gusto mo nang gawin is mag-convert ka muna ng mga kailangan mo i-convert. No? If you're gonna use your R with na ito, yung L, your liter times atmosphere over moles per Kelvin. Moles Kelvin pala. You have to convert your units. So, you're given na torr, convert mo muna siya to atmosphere, magka-cancel to. You get this atmosphere. Yung temperature mo, convert mo siya to Kelvin using the formula, you get this Kelvin. And finally, your volume, sabi niya dito, your weather balloon nasa volume of 7,240 cubic feet, binigay na yung conversion factor, you can just convert it muna to your to liters. Okay? So, ang question ay tinatanong, ano yung moles, number of moles, your N. Okay? So, when you solve that, solving PV equals nRT, your number of moles is equal to, so what happened here is, minanipulate niya lang yung equation. So, your N, so di ba, dinivide niya by RT. See akong pen. So, essentially, dinivide niya lang yan, both sides by RT. Okay, just using a, yan. Siya na, touchpad lang ito gamit ko. Ay, nangyari. Basta RT. RT. So, magka-cancel lang yan, di ba? Both sides. Cancel yan, cancel. May iwan yung RT dito. So, ito yung nangyari. Kaya na-form yung ganyang equation. So, nag-cancel sa side yung RT, nalipat sa kabila. So, PV over RT. Yan. And then you just plug in, no? Yung ina-convert mo na given, tapos you get your number of moles, okay? So, nakuha mo na yung number of moles mo. Pero yung tanong kasi dito, ilang grams? So, paano makuha yung grams? Madali na lang yun, since marunong naman na kayo mag-convert using your molecular mass, no? So, pwede mo nang i-convert using your grams per mole. Magka-cancel yung moles. Makuha mo yung number of grams. Okay? Ito sa to. So, yeah. So, medyo ganyan-ganyan yung mga problems sa gases. No? For the exam also, most likely, it will be like that. So, this is just a summary of the Boyle's law, etc. And then your ideal gas law. This is just an example of calculations, determining your molecular weight. Ano lang siya, again, parang pag manipulate mo lang din noong, kanina kinuha natin yung grams, dito kinukuha mo lang yung molar mass using your given. So, doable naman siya, basta meron ka ng grams, meron ka ng moles na nakuha mo from your ideal gas law. So, you get your grams per moles. Ganun din, pwede mo rin kunin yung molecular weight. I mean, your molecular formula. Just like what we're doing sa lab before. Para in-extend lang siya from your gases. Okay? So, yan. Ito lang din yan ginagawa natin sa lab na calculations. Na-involve lang yung gases. Okay. So, some more notes about your what do you call this? Your properties of gases. So we talk about the different laws, no? Your ideal gas law, which has been formed through different laws, like your Charles law, your Boyle's law, your Avogadro's law. And then there's another property of gases, which we now know as the Dalton's law of pressure. Okay. So the Dalton's law of pressure, it's just essentially saying na yung total number of moles mo, your total number of moles in a container is just the sum of the number of moles ng bawat component na nandoon. Okay? Isa pa. Yung total number of moles mo ng gas mo in a container is just the sum of all the number of of all the moles of each component na nandoon sa container mo. Okay? So that's your N total equals your species A, your species B, species C, etc., etc. So number of moles of A, number of moles of B, number of moles of C. Okay? So if you put in that equation sa ideal gas equation mo, pwede mo makuha itong formula na to. So your summation of A of your number of moles of A plus number of moles of B times RT over V is equal to your pressure of your total pressure. So pwede mo makuha pala based on this understanding of the Dalton's law of pressures plus your ideal gas law. Pwede mo raw makuha kung ano yung total pressure mo if you have more than two gas identities or gas species doon sa iyong container. So essentially, kung meron kang mixture ng dalawang gases or more. Okay. So yun lang naman sinasabi ng slide na to, na pwede mo makuha yung total, P total using this relationship. Okay. So using also this relationship, okay, ano ba? Dapat meron dito yun eh. Bakit wala? Hindi yata na ilagay. Ito pa lang sa next slide. Okay. Essentially, sinasabi lang naman niya, hindi mo naman kailangan i-memorize to or hindi mo naman kailangan i-solve to. Kapag kasi sinamarize mo tong equation na to, you'll just get or you'll just madederive mo na ang P total or yung pressure ng total is also just the sum of the pressures ng bawat component. So, ganun lang naman sinasabi niya. Na bawat component na yan, meron kang, pag pinag-add mo lang din yung pressures nila, you get your total pressure. Okay? Ito yun. No? Parang ginawa niya lang din is, binrake down niya yung, kasi di ba kapag ginawa mo to in algebra, you just multiply it sa bawat isang species. So, ganun yung ginawa niya rito. Di ba, ano ba tong formula na to? Di ba, this is also equal to pressure of component A. This is also equal to the pressure of component B, etc., etc. So, yun, no? Yun yung naging parang final na formula mo. That your P total is just the sum of all the pressures of the components that you have inside your mixture. And itong ano na to, slide na to is just showing you an application of that. Okay? Sure, tapos ayan, medyo complicated pala to. Yan. So yeah, you just plug in your ano. Ang ginawa niya lang is ginamit niya yung PV and RT to first determine yung pressure ng bawat component, and then pinag-add niya lang to get a total pressure. So because of our knowledge of Dalton's law of pressure, no, we can also determine yung tinatawag na partial pressures. Okay? Or yung parang counterpart naman niya sa in the number of moles is yung tinatawag na mole fraction. Yun yung X na nakikita niyo dyan sa screen niyo. Okay? So this is your mole fraction. It's a dimensionless quantity. It's just a fraction of your kumbaga para siyang percentage, kumbaga parang anong percent, parang ganun, ng component na ito yung total, hindi pala. Anong percent ng total components mo, ng total mixture mo, yung component na hinahanap mo. Ganun lang naman siya. So, for example, yung mole fraction mo of your component A is equal to the number of moles of A over your total number of moles, or your summation of your number of moles of A, B, G, etc., etc. Tapos, you can also use that in with also your pressure, using also the ideal gas law. Pag ginamit mo yan, pwede mo ma-determine yung pressure ng you can also determine the pressure of your component using the mole fraction times your total pressure. So parang sinasabi niya, since alam mo na kung anong percentage ng mixture mo yung hinahanap mo component, already just multiply that dun sa total pressure ng mixture mo. And you can also get the total or you can also get the pressure of that component. So very nifty, no? Pag parang ang dali niya gamitin. Parang yung idea na okay, pag alam ko na kung ilan yung moles ng or ilan yung percentage ng moles ng particle ng gas molecule ko dito sa container kong ito, alam ko na rin essentially kung ano yung pressure na ine-exert niya sa mixture. Basta alam ko kung ano yung total pressure ng mixture ko. So, yun yung use ng equation na ito. And these are just summaries of that. Okay. Parang ano lang to, sample lang kung paano niya ginagamit yung formula na yun doon sa kanina. And mapapansin nyo na yung mole fraction mo, whether you use the number of moles or you use the pressures, pareho lang yung nakuha mo sagot. So, ganun sila. No? Kumbaga related lang sila. Kahit gamitin mo is the number of moles or gamitin mo yung pressure tapos total pressure, pareho lang yung nakuha mong number of moles. I mean, nakuha mong mole fraction. Sorry. Yan. So, this is just parang example. No? The calculation. Ano naman ito pala? So, ayan, okay. Ito siguro, this is a typical gas experiment na ginagawa. Okay? So, for example, you have two tanks na connected by a valve. Each tank is filled with gas as shown. No? Both tanks are held at the same temperature. Tapos binuksan mo daw yung valve para daw mag-mix yung dalawang gases mo. So, after nila mag-mix, ang tanong is, ano na daw yung partial pressure ng bawat gas at saka ano yung total pressure nung mixture mo. Tapos tanong niya din, ano yung mole fraction ng bawat gas sa iyong mixture? So how will you approach this problem? Okay. So you have your plan here na sabi nga, di ba, your gas will expand to fill the available volume. So 5 liters plus 3 liters, ang total volume mo ngayon magiging 8 liters na. So you can use Boyle's law to calculate the partial pressure that each gas would exert after it expands to fill 8 liters. Okay? So, dito sa solution mo, you just use Boyle's law. So, your P1 V1 is equal to P2 V2. Or, so kapag hinanap mo yung P2, di ba, hinahanap natin yung bagong pressure ng bawat gas, you just use ito ay ibig sabihin niya ay second pressure or the final pressure of your oxygen component. So, your P1, V1 over V2. So, ano ba yung total, ano ba yung bagong volume mo? This is your 8 liters, di ba? Kasi nga, inopen mo na yung valve. Ang bago niyang volume na yun is yung total. Tapos, yung, ito yung given mo. You have your initial pressure and volume. So, makuha mo na kung ano yung pressure, bagong pressure ng gases mo. And then, your total pressure, again, katulad ng Dalton's law of pressure, kanina pinakita natin, it's just essentially that sum of them. Tapos, katulad din ng pinoint out natin na property noong nakita natin kanina, if you just get the ratio, either you use number of moles or you use pressure, pwede mo nang makuha agad yung mole fraction. You just, ito, ang ginamit niya, yung pressures lang. No? So, yung nakalculate yung pressure ng component over the total pressure, which is yung pinag-add mo lang, that's already your mole fraction. So, madali lang naman siya. No? Mukha lang komplikado sa umpisa. You just have to realize na nagbago yung total volume mo no? to take up both the spaces of both containers. Okay. So, ano naman to? Okay. Hindi na yan. Kasi meron siyang mag-graph pa ata. Okay. Natin yan. Reactions involving gases, parang hindi naman na. This is just very similar to chemical equations. Yan, no? Para ka lang din nag-stoic. Ito na lang. Taylor-Sachs law na lang. Okay. Ano yun yun? Again, okay, hindi masyadong focus on that. I don't usually try to calculate the gases that is formed from your reaction. So ito, Gay-Lussac's law, it's another law, no? So sabi niyo dito, imagine you have a balloon inside a container that ensures it has a fixed volume. And then painitin mo yung balloon na yon. So fixed volume dapat, tapos papainitin mo. Ano kaya mangyayari doon sa temperature sa loob ng balloon? Ano mangyayari daw sa pressure naman ng gas na exerted doon sa balloon? Okay, so constant ang volume, anong mangyayari? Ang iniiba mo ay temperature. Anong mangyayari sa pressure? So itong dalawang scientists, dalawang scientists na to, they were able to determine yung relationship nung pressure tsaka absolute temperature ng gas mo. So at constant mass and volume, your temperature is directly proportional to your pressure, okay? So yun, no? Yun yung Gay-Lussac's law. Na kapag constant ang mass mo at constant ang volume mo, yung pressure mo daw at saka temperature ay directly proportional. Which is parang parang hindi siya tama ba? Pressure. Constant volume. Tama. Okay. So yeah, so ito yung mathematical expression niya of that what do you call that? Of that relationship. Okay. Tapos you can just watch this video para yung sa experiment that shows it. So ano lang to, itong Gay-Lussac's law, para additional lang siya. Kasi enough na yung Avogadro's law, Charles law, Boyle's law, for us to define yung ideal gas law. And then, enough na yung pag-know ng Dalton's law of pressure for us to understand yung parang mole fractions na nangyayari sa iyong container, sa mga mixtures mo of gases. Itong Gay-Lussac's law, it's just another parang expression noong ideal gas law mo, pero focusing mainly on constant mass and constant volume, and ano yung relationship daw ng temperature and pressure in those areas. So, I think mas important na pag tignan natin itong kinetic molecular theory. Kung itong kinetic molecular theory is parang ito yung pagtingin kung paano nangyayari yung collisions ng mga gas molecules mo. Kumbaga, ano na yung nangyayari at the molecular level dun sa mga gases mo in your container. Okay? So, ang kinetic molecular theory, ano lang naman siya? It's also just trying to, it's a theory. It's trying to come up with a way to explain how your atoms, your gas atoms, are moving about, no, in your container. So ito yung mga niya, parang theories niya, no? Your gases consist of discrete molecules. Kumbaga, iba-iba, discrete or parang individual yung molecules mo, no? Hindi sila magkaka-combine. They are individual and they are moving in a continuous random straight line motion with different velocities. Okay? So yun yung parang assumptions niya, no? Ng kinetic KMT or kinetic molecular theory. Your collisions are elastic. Yun nga, there's no loss of energy. So, same lang to yung binabanggit ko kanina na kinetic molecular theory. Tapos, ayan. So, at a given instant, only a small fraction of molecules are involved in collisions. So, walang parang hindi natin kinoconsider attractive and repulsive forces. Okay, so given this assumptions, yung average kinetic energy daw ng gaseous molecules mo ay directly proportional dun sa absolute temperature mo of the sample. Okay? Alright. Yan. So, ano lang naman to, pinapakita niya lang na yung molecular weight, merong siyang effect doon sa molecular speeds at a given temperature. So, pag mas magaan yung molecule mo, mas ganito yung distribution ng speed. So, ito yung mas mabilis, mas mabagal. So, essentially, mas mabilis yung movement ng mga. So, this is at constant temperature, all at same temperature. Mas mabilis yung movement ng mga molecules mo pag magaan yung particle mo. On the other hand, kapag mas mabigat yung gas molecules mo, mas mabagal yung movement nila. Pero at the same time, mas consistent. Kumbaga, mas alam mo, mas maliit yung yung Gaussian curve mo kung saan yun yung speed ng particles mo. Okay? So, pero yun, mas mabagal nga siya compared sa kung mas magaan yung particles mo. Ito naman, this is for pag iniba mo naman yung temperature. So, pag iniba mo naman yung temperature, mas mabilis yung movement, yung speed. Pag mas at 25 degrees Celsius naman daw, mas mabagal yung speed. So, this is oxygen, no? Itong nasa graph na ito. Tapos, kapag 0 Kelvin nga, so, or as you approach absolute zero, sobrang steady na lang or hindi na gumagalaw yung mga particles. Okay? So we can explain the gas laws based on the kinetic molecular theory. Okay? So, yun lang naman yung gusto sabihin ng slides na ito. Tapos, yeah. Okay, so ito na. Ito na yung calculations ng speed. I think, ano ba? Ayoko nang i-include sa inyo yung speeds. Medyo complicated yung mga calculations niya. But yeah, hindi na lang. Sige. Huwag na lang itong mga speeds ng molecule, ng particles. Medyo complicated kasi yung calculations. Pero actually, plug and play lang naman yan sa sa calculator. Iba nga lang yung R na ginagamit ko. Yung joules na version. Take note pala na ang joules ay equivalent to kilogram times meter squared, okay? So, yun yung SI, SI unit niya. So, if you're gonna convert that, yan ang equivalence niya. Okay, diffusion and infusion of gases. Yan. Ito medyo madali lang naman ang calculate. Rin. Kasi yung calculation nitong diffusion. Anyway, na-describe ko na ito kanina. Na lang. I think ito yung mas mahalaga. So, katulad yung sinabi ko kanina, what we have been discussing so far ay ideal gas, no? Ideal gas laws. Again, in the real world, hindi nag-a-apply yung what we know about ideal gases dito sa in the real world, okay? Kasi in the real world, may mga deviations talaga from the ideal gas law. Especially kapag mataas yung pressure mo or mababa yung temperature mo, which is katulad yung sinabi natin kanina, no? So, apart from the ideal gas law equation, meron din tayong tinatawag na real gas laws equations. Yan. So, kapag based on the kinetic molecular theory at saka yung calculations ng movement ng gas particles mo, you can actually determine or parang pwede ka mag-set up ng equations para this time to consider also the other forces of attraction. First, di ba, number 1, yung isa yung intermolecular forces of attraction mo. Pangalawa, to consider also yung tawag nila? Yung volume ng iyong mga gas particles, okay? So your volume and your gas particles, your volume of the gas particles and your intermolecular forces of attraction, pwede mo na sila ngayong gawan or mag-set up na equation para isama doon sa ideal gas equation mo so that we can achieve an equation for the real gases. Kumbaga, what's happening in the real world. Okay? So yun yung reason bakit diniscuss yung, or bakit sinama sa discussion yung KMT, kinetic molecular theory, pati yung yung nauna rito na ano ito? Yung mga yun nga, yung your KMT, tsaka yung motion, yung speed yan, yung molecular speeds mo. Kasi once we understand how those are working, we can now set up equations para pag-usapan yung real gas laws. Okay? So meron yung tinatawag na van der Waals equation. Okay? So the van der Waals equation now incorporates, kamukha niya yung ideal gas law equation, pero it now incorporates certain, what do you call this? Certain variables that can now also determine or parang it gives you an equation na meron na di ba yung ideal gas to, sobrang simple nga natin. PV equals nRT. Ito, meron na siyang additional na variables and these variables correspond to your intermolecular forces and the volume of your gases. So yung mga tinanggal natin kanina doon sa ideal gas na mga na mga assumptions natin, di ba? Nag-assume tayo na ganito siya, elastic siya. In-assume natin na walang intermolecular forces. Ngayon, we have to incorporate them to understand what's happening in the real world for the real gases. That's why meron yung na-form na real gas law equations. At yung real gas law, isa sa mga yun ay yung van der Waals equation. Okay? So yan, isa yung sa mga ginagamit na equations. So, yan, okay. So, ano lang naman to, again, it's just similar to the ideal gas law, pero nadagdagan lang noong A tsaka B. No? Itong units na ito, pati itong units na ito. So, paano makuha yun? Sir, paano namin makuha yung A tsaka B? Actually, may table for that. Kunyari, hydrogen, dapat given yan. And what you have to do lang is to plug it in dun sa equation mo. And you get a different answer from your ideal gas equation. Okay? So, kung ang problem ay sinabi, ammonia gas, ang A at B mo, matik na yun, titignan mo lang sa table, ito yung A, ito yung B. Again, what you just have to watch out for is yung iyong units. Okay? Just make sure that your units are consistent such that at the end of your dimensional analysis, magka-cancel out lahat. So, makikita nyo rito, ay, nangyari. Yeah. So, makikita nyo rito, no? Pag pinlog in mo na lahat kasama na yung A at B, magka-cancel na yung mga liters per mole. No? May iwan na lang yung atmosphere. Ito, mga liters. Ito, liters squared to, di ba? Ito, in-square mo yung liter. So, ganun din. Magka-cancel din siya. Ito, mole squared. Ito, mole squared. Magka-cancel. Huh? So and so forth. No? Ganun din sa right side ng equation. Magka-cancel ito. Cancel ito. Cancel ito. Cancel ito. Your liters will cancel. Cancel mo. Cancel yung liters mo. Your Kelvin will cancel. Yan. Tapos, ang wait, 0.5 liters. I think yung tapos 0.0821 liters. Your liters will cancel. Ay, mali pala. 1. 0.457. Ito pala. 24.5 liters. So, dito na siya nag-cancel pala. Pero dito dapat. Anyway. Sige, basta ganyan. It should cancel here. So, yung liters, magka-cancel siya pag pinagsama-sama mo na yung terms. So, yun. Parang ganun lang siya. It's really easy to use. Siguro, hindi naman ako masyadong, siguro I'll just give 1 or 2. Baka 1 nga lang. Kasi I don't really, I mean, for introductory topics of gases, hindi masyado talagang, yung real gases. Pero, yun, no? But just for you to know na what we're talking about in the ideal gas laws are not literally what's happening in the real. So to understand further, those were just models, no? And they're good models to understand what's happening. Pero if we want to really know what's happening, you have to incorporate yung mga different forces of attraction, for example. And one of the ways to do that is to add into our equation yung other components nga na that would factor those in. So we have the van der Waals equation, which is a real gas equation. So hindi lang van der Waals equation ang real gas equation. Marami pang different equations by different researchers, and they make use of a lot of other considerations, no? May mga other constants sila na hindi na natin tatakil. Okay. Yun, okay. So that's it for the gases. Ipasadahan na natin. Konti na lang naman.